wanted to start off today's talk just by talking a little bit about why we moved to cloud in the first place. So we're trying to get on cloud because we want something that is fully flexible, fully managed by someone else, where we still get all the latest technology and a fully reliable service. But I think what's core to that is that there still needs to be some group of trusted people who are there delivering the service to you, who are there operating this service. What we're showing here is some very productive Google engineers, having a chat one day. And this is going on every day at Google. These people are writing the software that's running the data center. They're restarting the machines if there's something wrong. And they're the ones who are really responsible for making sure that you get the service that you know and love the best. So core to that is really this trust equation, which is always going through your mind, which is, am I secure in the cloud? Can I trust these people who are working to secure my cloud? Is my privacy being protected? Are these people just accessing my information without my knowledge? And is my service available when I need it? Are these people actually doing the job of keeping this service up and running and giving me the service that I'm paying for? And these things are all in a delicate balance with one another. We don't want to give our engineers unlimited privileges so that they can just go and fix any error at any time really, really quickly. But also, we don't want to make life impossible and lock all access down to the point where you yourself go to click on your information and it says data unavailable because it's locked down. And so what we want to talk about today is what we see as the foundation of addressing these needs. And really, it's built on three things: great technology, world-class operations, and full accountability. And at Google, we see the cloud provider as needing to take the lead on the technology and operations side. You need to trust us with the technology and operations and make sure that we're doing the right thing. Because otherwise, what's the point of being on cloud? If you have to constantly manage what we're doing, you may as well have your own data center. But on the accountability side, this is where you come into the equation. We want to give you transparency over what's happening, what's happening with my data, how can I control it in certain cases where I have special needs. And we're going to talk to you a little bit about some sort of exciting products we've released at Next, as well as the products we've been working on over the last few years later on in this presentation. And so I'm now going to hand over to Ollie. He's the software engineering lead for access transparency and access approval. And he's going to talk a little bit more about the technology and operations side.
Thank you, Joe. So I'm going to start by talking about the technology that Google employs to ensure that we're able to provide the security, privacy, and reliability needs that our customers have. Now, compute infrastructure faces risks at all levels of the technology stack. And so consequently, Google has adopted an end-to-end security story that extends all the way from the low-level hardware all the way up to the applications that ultimately touch and process your data. I'm going to talk through each of these layers. Let's begin with the hardware. Now, most consumers, when you purchase a device from your hardware vendor, you assume that that device comes to you in the pristine state that the manufacturer intended. However, at Google, supply chain attacks are a very real concern. We need to have strong guarantees that that hardware has not been tampered with in transit. And so we've developed Titan, which is a crypto processor responsible for verifying the integrity of our hardware. Before the first instruction is executed on that machine, the Titan processor verifies that the firmware on that device has not been tampered with. And that allows us to enable a hardware root of trust upon which all of our other security controls can be built. Now, Google has a large number of machines, and they exist in a variety of states. We have different versions of hardware, different versions of software, machines that are in maintenance, machines that are actively running, machines that are in the process of being booted. And so we needed to have a scalable way of ensuring that every machine in our fleet comes to a known secure state before we're able to run production workloads on those machines. And so let's look at the boot process. This is a typical machine boot process. You power on the device. The BIOS is loaded from firmware. It executes, does some initial configuration, loads the bootloader, which in turn loads the kernel, which ultimately mounts the OS image containing most of the software running on that machine. Now, engineers at Google have worked to harden each level of this layer of this boot process. We've removed unnecessary code. We've identified and fixed security vulnerabilities. In many cases, we've contributed security vulnerabilities in the we've contributed security fixes in the Linux kernel directly to the upstream community. Furthermore, now that we've established a hardware root of trust with Titan, we can use each layer of this boot hierarchy to verify the next layer. So Titan verifies the firmware, the BIOS, which in turn verifies the bootloader, which in turn verifies the kernel, which in turn verifies the OS image. And in doing this, we develop a cryptographic chain which can be verified and validated to ensure that once we've completed our boot process, that machine has entered a known, secure baseline state. Only then can production workloads be put on that machine. Now, in reality, machines don't exist in isolation. They interact with other machines across the network. They interact with services. They interact with humans. And so each of these identities on the network is given a cryptographically secure identity. We need to have trust that a machine is the machine it says it is, and that it has not been compromised in some way. So we just saw the process via which machines boot up, from the hardware through the boot process that ultimately generates a cryptographically secure chain of trust. That needs to be validated before that machine can take on an identity. And only after the machine has taken on an identity can it interoperate with other services on the network. The same holds true for our service identities and for our people identities. And we'll talk a little bit about the requirements for each of those a little later. Now let's talk about storage. All communication in Google's cloud platform to it and within it is encrypted via TLS. Once your data is uploaded to the cloud and subsequently written to storage, that data is split into chunks. Each chunk is secured with a unique encryption key. And those keys are stored in our highly secure key management service. It's worth noting that only services that have a valid need to access that data are allowed to download those keys. So for example, the Google Cloud Storage, the binaries that run the Google Cloud Storage system can only download keys associated with Google Cloud Storage data. They can't get access. They cannot decrypt data belonging to Cloud Bigtable or any other service at Google. Now, last year, we launched a service called Binary Authorization. And this is designed to provide strong guarantees around the integrity of the binaries running in your production systems. Binary authorization ensures that only images that have gone through your organization's internal build and vetting process can be deployed to Kubernetes engine. Google has its own internal version of binary authorization. And this provides strong guarantees that all code deployed to production has been checked in to long-term source control. It's been reviewed according to Google's internal processes. And it's been built in a verifiable, repeatable fashion so that we can go back. We know exactly what source code went into that. We understand exactly what build parameters went into that. Only once all of these requirements have been met can that code be deployed to a production. And only then does it obtain an identity that allows it to interact with other services on the network. And it's worth noting that the identity does not grant broad access. As we mentioned earlier, We have fine-grained access controls that ensure that service can only access the data that is necessary to run that service. All right, now, contrary to what you may have heard in the news, the great AI awakening has in fact not yet happened. We still employ people. And so I want to talk through some of the safeguards we have in our operational controls to protect you and your data from insider threats. Let's start with the data centers. Ultimately, this is where your data resides. And so Google takes the security, the physical security of our data centers very seriously. We have fingerprint scanners. We have optical retina scanners. We have laser beams. I joked internally, asking when we were going to get sharks, and they informed me that in North Carolina we do in fact have alligators. Once a Google employee has gained access to a data center, their ability to move within the data center is still restricted. Google employees are only able to access locations for which they have a valid business need to be there, and they need to badge into each new location that they enter. Those badging events are logged, and we have auditing after the fact. We also have a number of safeguards in place to protect our employees on the network from being compromised. All employees have to use a phishing-resistant hardware authentication token. These are the standard USB fobs that you're aware of, and you can actually purchase these for use by your own employees if you're using our cloud platform. We also require all access to go through a device which is managed by Google. I, as a Googler, cannot log into Google, cannot communicate on the network from my personal machine. I have to go through a device that's managed and maintained by Google. And only after these two conditions are met do I obtain a cryptographic identity that allows me to interact with services on our network. We've also engineered security and privacy best practices directly into our operations process. Each individual at Google has a role, and there's certain access that they need in order to perform their job responsibilities, but they are restricted to fine-grained access controls ensure that they only have the access needed to perform their job responsibilities. All of our support tools, when you call Google, when you log a support request, you need help with a problem. The support engineer cannot access your data without providing the support ticket associated with that call so that we have a clear record and a clear understanding of what that access is for. And all accesses to user data are logged and audited internally. We also take measures to reduce the need to touch user data at all. Many of our common support and maintenance operations are automated. They're hidden behind access-controlled APIs so that an engineer rarely has a need to SSH into a VM to help you debug a problem. Most of the common tasks can be automated without requiring that level of access. Similarly, many of our internal dashboards strip away user content. They use internally identified unique IDs rather than the names that you assign to your projects and your VMs, so that no personally identifiable information is conveyed via these dashboards. All right, now I'm going to hand things back to Joe, who's going to talk about some of the technology that allows you to hold us accountable.
Awesome. Thanks, Ollie. So we've heard a little bit about the technology and the operations, this chain of trust that stretches all the way down to the hardware, all the way up to the way services gain identities, the way people gain identities, and the way that our operations are run is really built on top of all of that. And so our focus for the last few years has really been on surfacing all of this chain of trust to you in a way that allows you to make decisions about how you want us to use your data. We've had this phenomenal set of, internal visibility and controls. And while you in the past have sort of had to put your data on the cloud and just sort of trust the cloud provider, we're now making all of this available to you through access transparency and access approval. Access transparency has been available for a number of GCP services stretching back to last year. And we're excited to announce that there's a number of new services that join access transparency this year in both GA, beta, and alpha. And I'll speak to a little bit more on the next few slides. Access transparency gives you the near real-time logs of these administrative accesses to your data. As Ollie was talking about before, each of these support tools, even when we stretch all the way down to an engineering level access that's made from a command line tool, is collecting and validating a business justification. We're taking that justification up and surfacing it to you so that you can check it against your own processes. And I'll go into this a bit more detail in a second. Access approval is a new product that allows you to pre-approve those accesses where eligible. And what that's going to do is require that Google employee, even if they're very highly privileged, to request access from you beforehand before they're even able to see any information at all. So let's look at an example of how this works in practice. I want you to imagine that it's late at night, you're trying to fetch a file frantically off Google Cloud Storage, and lo and behold, something seems to be wrong with it. It looks like it's corrupted. You need to call Google Cloud Support to get it fixed. Now, things that you do on GCP and that your employees do on GCP are audited by cloud audit logs, and you get a clear record of what happened. You attempted to access your bucket, you tried to read this object. So you telephone Google support. Google's frontline support teams have very heavily restricted access to data. They cannot see what's inside your bucket. But what they can see is certain things like the bucket access control list. Now, in many cases, people refer to these pieces of data as metadata. At Google, we just include all data that you give us as your data. We don't make value judgments about sensitivity levels or anything like that. We will, if you give us it, we will track it, we will log it, we will apply our access controls to it, and we will surface the accesses to you through access transparency and bring them into scope for access approval. Now, even though all the support technician is trying to do is see who has access to that bucket, with access approval on, they're going to get access denied. It's not until you actually approve that access that they can go ahead and read that access control list, at which point they generate an access transparency log. So you now have an end-to-end flow showing what got touched, why it was touched, when it was touched, and by whom. Now, let's say that there's still an issue. Everything seems fine, you have access to the resource, there's no reason why this problem should be happening. We need to go ahead and escalate to Google engineering. Now, this is going to go to one of the engineers on the Google Cloud Storage team. These are the people who actually built the service. They're responsible for maintaining it. There is a serious issue. We need to get this resolved. Now, even on these, like I said, even on these lower level engineering tools, again, we're getting that ticket coming through. We're getting this access denial process, and they're having to request access from you, a customer, before you're able to access the data. I will stress that outage and legal access are excluded at this point. That's just to stop situations where we have a multi-user affecting fault and everything's on fire and we may need to go ahead and do something. Got very strict processes around those. But for the large part, you'll be approving that access and we generate an access transparency log of that information as well. So you can turn this on. Access transparency requires that you have platinum or gold support or equivalent, and access approval requires platinum or enterprise support. Access transparency can be enabled today on the GCP website, but you should contact sales or support for access approval information. Now, for the vast majority of customers, really the Google managed access controls that we've been talking about for much of this presentation, plus maybe some additional transparency through access transparency, are going to be 100% sufficient for your use cases. Access approval is a very heavy-duty control. It enables you to fully manage the access to your data, and it's suitable for cases where you might have really highly sensitive information, but for the large part, you probably want just the flexibility of being able to call up support and have them address your issue immediately. So what's it available for? We're excited to announce access approval beta is enabled for 10 services. So there's the full list here. It's so long I won't even read them anymore now. So access to transparency beta is also enabled now for GKE, Spanner, and Dataproc, which we're very excited to announce. And we've also got another 6 services entering alpha too. You can read more about this on our website, so I can probably jump to the next slide. Now, as we've spoken about, while you may hear from other cloud providers that there's sufficient tooling in place that covers the support level, what I really want to stress is that we have coverage not just over the support custom tooling, but also the engineering internal application APIs, as well as general purpose storage systems that may be accessed by engineering. This is going to give you visibility and control all the way down the stack to the deeper control paths where you have someone who is highly privileged who is accessing information. I'm now just going to give a quick video demonstration of how something like this might work. Now, I'd love to do this live, but it involves people who are on call and highly privileged, so it's much smoother to pre-record. But we're just going to jump in and show this demo now. So imagine you're browsing Google Cloud Storage, you get some error that you're getting permission denied on Cloud KMS key, and you can't figure out what's going on. So you're going to click that support button, send a support ticket, and here's what the support technician will see. They're going to need to enter a justification in order to access your data. Now, this is a simulation because obviously we can't show you our internal tooling. But what I want you to note is that there's a case number that's being entered there, and that individual case number is being programmatically validated. So 1, 2, 3 are the last 3 digits of that case number. Just keep an eye on it because you're going to see it a lot more throughout this presentation. So they're going to go and attempt to access that information, but before they're able to do that, you'll need to approve it through access approval. So what you're seeing now is you can clearly see the resource that's being accessed, when it was requested, how long the access is needed for, the country of the accessor, and there you go. It's the case reason that we opened up before, the same reason number. So we have this already, starting this chain of end-to-end visibility. Let's go and approve that access. Now, in the background, support are going to go ahead and work out your issue for you. Let's get that resolved. You're going to go back, try and access that file again, and voila, it works. You can download the file. I don't know why you would store the Google logo on your GCS bucket, but let's just say you have. We're going to now jump into stack driver logging. In stack driver logging, you can pull up now the access transparency logs. You can see exactly what this support person did, when they did it. We can see, this is how you know this is real, because we include the loading screens as well. We can see here all of the accesses that were made. Really, it's just someone who was trying to see which buckets I had in my Google Cloud Storage system. And there again is my case number, so I can see 202.123. This all looks fine to me. It's a pretty benign operation, and I have the full audit trail. I also get the audit logs of people who inside my organization who approved any access. So I can use that to get a full audit trail going all the way back. So let's dive into a little bit more detail. What do you get? You get at the top of every access transparency log the location and sort of entity information about who and where your data was accessed from. And then you also get some information about exactly what happened. So in this case, I can see that it's just the access control list of the bucket that's being looked at. It seems pretty benign to me. It's all good. And then again, like I said, you get both the reason type and the reason detail. So all that end-to-end auditability is there. For access transparency, we include all non-outage human access for support, and it's included in access approval as well. Now, outage accesses, you'll get the access transparency log, but like I said before, there may be certain cases where we need to hit that big red button and go ahead and bypass access approval. You'll still get a log of that information if that were to happen. Legal accesses, this is a bit of a tricky area. You get these unless we're prohibited by law from surfacing them in access transparency. However, they're not included in access approval. System access, these are those things that Ollie was talking about before. You know, the binary goes to access the information. We've got that binary authorization control in place. So showing you how our transparency really builds on that chain of trust that we established earlier in this presentation. Because of that binary authorization control, we exclude the system access from access transparency and access approval, and that just allows the software to go ahead and run and do exactly what you expected it to do without you needing to intervene. Underlying storage access is included in access transparency, but it's still coming soon to access approval, so stay tuned for more updates there. So we've covered today in depth how you get the full transparency, and now you get these new controls that stretch all the way up from the lower level systems to the higher level access. And we've also covered how our chain of controls from our hardware all the way up to the application layer and through our operations is reflected in what you see in these access transparency logs and how you use access approval. But for those of you who need more information, we've got some detailed tech white papers. I encourage you to search for our encryption, data deletion, and security white papers. We have more coming out very shortly that will talk a lot more about the details we've covered in this slide. We also have compliance certifications that audit many of the controls that we've spoken about in today's presentation, as well as our annual transparency report that looks at government access, if that's of particular interest to you.